Every star, every galaxy, every atom in your body was once packed into a space smaller than a single proton, so what was there before that moment? By the end of this video, you will see why answering that question forces physicists to rethink whether time itself had a beginning, or whether the word "before" makes any sense at all. In the first trillionth of a second, the universe ballooned from that proton-sized point to roughly the size of a grapefruit, a speed of expansion that no known law of physics can explain. But here is what almost nobody realizes: physics does not actually break at the Big Bang itself, it breaks 10 to the minus 43 seconds after, at a barrier called the Planck wall, beyond which every equation returns nonsense. Below that scale, Einstein's general relativity and quantum mechanics both apply to the same situation, and their answers flatly contradict each other. So when scientists say, the beginning of time, what they actually mean is, the edge of what current mathematics can read, and what lies beyond that edge is the most fiercely contested question in modern physics. What do the leading theories say was on the other side? Let us start with the one most cosmologists quietly accept when nobody demands they prove it. Eternal inflation proposes that our universe is not the universe, it is one bubble that popped out of an endless, churning sea of quantum energy that has no beginning and no end. That inflationary sea never stops. Right now, elsewhere, other bubble universes may be nucleating, each one carrying different fundamental constants, a different speed of light, a different electron mass. The troubling consequence is that eternal inflation predicts roughly 10 to the power of 500 possible bubble universes, making it nearly impossible to falsify, a beautiful theory physics cannot yet test. Can we do better than an untestable theory? That is precisely where the second model picks up, and it brings an entire dead universe back into the story. In 2001, Paul Steinhardt and Neil Turok proposed the Ekpyrotic model. Our Big Bang was not a beginning but a collision, two enormous membranes crashing through a higher spatial dimension. These membranes, called branes, float like two sheets of paper in a fifth spatial dimension, and when they slap together, the kinetic energy of that impact becomes the heat and matter of a new universe. Each collision naturally produces a hot, flat, uniform fireball, exactly the initial conditions astronomers observe when they map the earliest state of our universe. But if the universe is truly bouncing, should there not be a fingerprint from the previous cycle encoded somewhere in the sky, and one physicist claims it is already there, hiding in plain sight? Roger Penrose's conformal cyclic cosmology predicts that supermassive black holes from a previous universe left faint circular rings in the cosmic microwave background, and he argues those rings appear in real satellite data. Most cosmologists say those patterns are statistical noise, but this is a real, falsifiable prediction based on real data, which puts it a step beyond purely mathematical storytelling. But here is where it gets genuinely strange. Stephen Hawking and James Hartle built a model that makes asking what came before the Big Bang as meaningless as asking what lies south of the South Pole. In their no-boundary proposal, near the Big Bang, time is not a line you can trace backward, it mathematically transforms into a spatial dimension, and the very concept of before simply dissolves. This is not philosophical hand-waving. Imaginary time is the same mathematical tool Hawking used to correctly derive the temperature of black holes, a result later verified independently by multiple researchers. The no-boundary universe is therefore self-contained, it has no edge, no external cause, no before, it simply is, in exactly the way a sphere simply is, with no point that counts as its surface's beginning. And yet a completely separate branch of physics, loop quantum gravity, reaches the opposite conclusion, insisting time was never erased and that a full universe existed before ours. In loop quantum cosmology, space is not smooth but stitched from discrete quantum loops roughly 10 to the minus 35 meters across, and when a collapsing universe compresses to that scale, those loops push back hard. That quantum pressure is strong enough to halt the collapse and reverse it, turning what would have been an infinite singularity into a finite bounce, and our Big Bang is precisely where that bounce peaked. Work by Abhay Ushtekar at Penn State shows the singularity is completely eliminated, there was never a moment of infinite density, the universe transitioned smoothly from contraction into expansion. So which version of before is real? No before at all, an eternal sea of bubbles, colliding branes, or a quantum rebound. Every one of these passes every observational test we have applied so far. The tiebreaker may be coming. Primordial gravitational waves from inflation and from a bounce carry different frequency signatures, and the planned LISA space detector is specifically designed to distinguish them. James Webb is already adding pressure from an unexpected direction. Its images reveal massive galaxies fully formed just a few 100 million years after the Bang, forcing cosmologists to revise their models. And in 2023, pulsar timing arrays, networks of millisecond pulsars used as a natural clock spanning our galaxy, detected a faint gravitational wave background threading the entire observable universe. Some cosmological models predict that background carries the imprint of events before our Big Bang, making pulsars the first instruments ever positioned to hear something from before time, as we know it, began. We are the first generation of humans with instruments sensitive enough that the question of what came before everything has crossed from pure philosophy into experimental physics, and that crossing just happened. Every equation, every detector, every prediction you just heard was conceived inside roughly 3 pounds of matter sitting behind your eyes, inside a universe it is simultaneously trying to explain. The universe spent 13.8 billion years fusing atoms inside dying stars, scattering those atoms across galaxies, and rearranging them until some became capable of wondering where the universe came from. That recursion is not accidental. Before the Big Bang may always remain the horizon we sail toward but never reach, and maybe that is exactly the right size for a question, large enough to keep you moving, never small enough to let you stop. Follow Science Explained daily for more.